Have you ever wondered what happens when two neutron stars collide? To comprehend this cosmic drama, we first need to understand what neutron stars are. Imagine a star much like our Sun, but about 1.5 times its size. This star burns brightly, fusing hydrogen into helium in its core for billions of years. Eventually, the hydrogen runs out, and the star begins to fuse helium into heavier elements. This process continues until the star's core is primarily iron. At this point, the star can no longer sustain fusion and collapses under its own gravity, triggering a supernova explosion. What remains is a dense, compact core, known as a neutron star. These celestial bodies are not your average stars. They are incredibly small, about the size of a city, yet they pack a mass greater than our Sun. Their density is mind-boggling, comparable to packing a Boeing 747 into a grain of sand. Neutron stars are primarily composed of neutrons, hence the name, with a thin crust of iron on the outside. Now, let's introduce a second neutron star into the mix. These pairs are rare but not unheard of. They are often remnants of binary star systems, where two stars orbited each other before going supernova. Over time, gravitational forces cause the pair to spiral towards each other, setting the stage for a collision. The significance of such an event is astronomical, quite literally. Neutron star collisions, or mergers, are thought to be responsible for some of the universe's heaviest elements. Gold, platinum, and other precious metals may owe their existence to these violent encounters. So, the stage is set, two neutron stars spiraling towards each other. But what happens next? Well, that's a story for our next scene. Stay tuned as we delve deeper into the mystery of neutron star collisions. When two neutron stars approach each other, they don't immediately collide. Instead, they perform a cosmic dance of death. This dance is orchestrated by the incredibly potent force of gravity. In fact, the gravitational pull of neutron stars is so intense that it warps the very fabric of space and time around them. Picture two dancers spinning around each other, their steps guided by the rhythm of the universe. As these colossal bodies draw near, they begin to orbit each other. This isn't a leisurely waltz, however. They're moving at a speed of hundreds of kilometers per second. It's an intricate, high-speed ballet choreographed by the laws of physics. Their orbits gradually tighten as they emit gravitational waves. Now, these aren't waves you could surf on. Gravitational waves are ripples in the fabric of space-time itself, caused by the acceleration of massive objects. Albert Einstein first predicted their existence in his general theory of relativity, and they were finally observed directly in 2015. These waves carry away energy, causing the neutron stars to inch closer and closer. The pace of their dance quickens. The gravitational waves increase in frequency and intensity. It's the grand crescendo of their cosmic ballet. The stars, now locked in a deadly embrace, are spinning so fast and so close that the space between them is less than the width of a city. They're on the brink of collision, but the dance isn't over yet. Their gravities are so strong that they begin to tear each other apart. It's a process called tidal disruption, where the gravitational forces are so extreme that they start to distort and stretch the stars' shapes. After spiraling closer and closer, the neutron stars finally collide. But this is not the end. Rather, it's just the beginning. This dramatic event, however, is a topic for another scene. For now, let's revel in the awe-inspiring spectacle of their dance, their last waltz before the inevitable collision. The moment of collision between two neutron stars is nothing short of spectacular. It's a cosmic event that outshines everything else in the universe. But what really happens when these two dense objects meet? Imagine two stars, each with a mass greater than the Sun, but compacted into spheres only about 12 miles wide. They've been spiraling closer and closer together, their gravitational pull causing them to speed up until they're spinning around each other hundreds of times a second. And then, in a fraction of a second, they collide. The impact is unimaginable. The combined mass and extreme speed result in a release of energy that is mind-boggling. This isn't your average explosion, it's a kilonova, 1,000 times brighter than a typical nova. For a brief moment, this collision outshines the entire galaxy. But there's more to this spectacle than just a brilliant flash of light. The collision of neutron stars is a cosmic forge, where the pressure and temperature are so extreme that they can create elements heavier than iron. Yes, that's right. The gold in your jewelry, the platinum in your car's catalytic converter, they were likely made in a neutron star collision billions of years ago. We are quite literally stardust. The aftermath of the collision sends shockwaves throughout the universe, both literally and figuratively. The material ejected in the explosion travels at about a third of the speed of light, spreading these newly formed heavy elements throughout space. Over time, these materials may become part of new stars, planets, and even life. The collision creates a spectacle of cosmic proportions, but its effects are far-reaching. It's not just a show, it's a cosmic factory, a creator of elements, a shaper of galaxies, a key piece of the puzzle of how our universe works. It's a reminder of the incredible power and beauty of the universe we live in, and the mysteries it still holds for us to discover. The collision of two neutron stars leaves behind a rich legacy. After the spectacular explosion, there's a dense cloud of matter, a byproduct of the collision. This matter, composed of heavy elements, is ejected into space, seeding the cosmos with elements like gold and platinum. Sometimes the remnants of the collision are so dense that they collapse under their own gravity, forming a black hole, a point in space where gravity is so strong that nothing, not even light, can escape. Studying neutron star collisions is a key to unlocking the mysteries of the universe. They give us clues about the life cycle of stars, the creation of heavy elements, and the extreme physics of black holes. So the next time you look up at the night sky, remember the cosmic ballet that's taking place billions of light years away. Don't forget to subscribe to our channel for more fascinating insights into the universe, and leave your thoughts in the comments below. Until next time, keep wondering and keep exploring.